All right, how's everybody going? Professor Bryant, another installment, Workout Wednesday. Today, our focus is going to be on Chapter 23, Transition Metal Complexes. I wanted to go through a couple examples from the text on determining the coordination number as well as determining the oxidation number of the metal. And then we're also going to do some nomenclature as well. So let's take a look at each of these examples. So what we have here is 2325 question. It says indicate the coordination and oxidation number of the metal for each of the complexes. I am specifically on purpose going to add in the nomenclature part because nomenclature is always going to be helpful. And we'll also, for a couple of these examples, go ahead and derive the structure, and I don't mind writing some of the structure. I think the structure and understanding the structure is going to help people tremendously when dealing with this. So let's take a look at the first one. Na2 parentheses CdCl4 in parentheses. So remembering from our understanding of transition metals, first off, we need to just go ahead and underline what is the transition metal. In this case, the transition metal is cadmium, right? Cadmium. So we're dealing with cadmium. Now, what is the overall charge of cadmium? Clearly, cadmium in this case is the anion, right? How do we know that? Well, the transition metal complex is always within brackets, and the coordination sphere is always within brackets. So this determines coordination number. And therefore, if we have 4 chloride ions as ligands to our cadmium, then the coordination number, and you'll see me just abbreviate that as coord number, has to be 4, because that is the number of ligands inside the coordination sphere, right? Remember, this is the coordination sphere, and I'm going to do that for this one, and then we won't have to redo this for all of these. Okay. If the coordination sphere has to have a net charge of -2, how do we know that? Because sodium brings a +2 charge as the cation here. Then the cadmium, if all of the chlorides are -1, the cadmium must be 2+, right? So the coordination number is 4, and the oxidation number is 2+. Okay? Now, what does that mean for this example? That means that cadmium must be in what is going to be expected to be a tetrahedral arrangement of atoms where we have a 2+, we have a negative charge on all the chlorides, but the coordination is 2- in entirety, right? So this would be the structure. Outside of that structure, right, you would have 2 sodium ions that are outside of the coordination sphere. So there is your structure for A. And now, if we wanted to talk about the nomenclature, right, the nomenclature, we want to go cation first because our transition metal is the anion. So the cation is sodium. And then we want to go with the transition metal and its ligands first. So we're going to use tetra because there are 4, chloro because that is the prefix or the utilization of chloro, and that's based on, remember I gave you the reference materials here, chloro, based on that table. You will have that for your assessments. Tetrachloro cadmiate cadmiumate 2. Now, for some of these situations where cadmium and some of the different metals, you may see issues with the ending, but remember it needs to be ATE if it is the anion. ATE if it is the anion. So I would accept this tetrachlorocadmiumate 2, and sodium being the cation. Okay, so let's go back and take a look at another example. K2MOOCl4. Actually, let's do C. Let's do C because let's do one where it is the cation. So CONH3,4Cl2. So we'll do C, and we have in parentheses CO parentheses in bracket, excuse me, NH3 4Cl2 Cl. Okay, so we know coordination sphere. We're dealing with cobalt as the metal. The coordination number is 6 because we have 6 things around it, and I should use equal signs instead of dashes. Coordination number 6, we have 6 ligands, and the oxidation number is equal to, well, we know ammonia is a neutral ligand, brings no charge. Chloride brings 2 negative charges. We have a negative charge chloride outside of the coordination sphere, which means that the entire coordination sphere has to have a net charge of +1. Therefore, cobalt we're dealing with is 3+, so the oxidation number is +3 or 3+, either way. Okay, so when we talk about structure specifically, we are dealing with octahedral situation, right? So we're dealing with cobalt with 6 ligands, and the organization of these ligands we have not talked about specifically. I will not be asking you questions on cis and trans. You will we'll get into that in organic chemistry a little bit next week. But I just hope that you are able to just draw a structure that represents one of the structural isomers of this particular compound. And again, we have an overall net charge of +1 and a chloride ion. Okay. Again, octahedral, these chlorides could be in multiple different positions, right? They could be in the axial, or they could be perpendicular to one another. All right, so there's your structure. Now, we're dealing with a situation where the cobalt is the cation. So from a nomenclature perspective, we have 2 different ligands. Remember that the alphabetical order is what dictates the order. So we are dealing with tetraamine, dichloro, cobalt 3, and then the anion in this case is chloride. Now, this is a generic name that does not give any insight into the structure and the positioning of these ligands. This is just a generic name. I'm just getting some generic name practice. Why is amine before dichloro? Because A comes before C in the alphabetical order. So that is structure, name, coordination number, oxidation number. Let's do one more. And let's see. And let's take a look at F. So if we're doing question 25, F is zinc En2Br2, okay? So we got zinc En2Br2, okay? We have within the coordination number, well, transition metal, we're dealing with zinc. Coordination number is based on the coordination sphere, but we must remember that En, or ethylene diamine, En is bidentate. We are dealing with a structure that has two amines like such, and those lone pairs on those amines can bond in two different positions on the orbitals of a particular transition metal. So just because we only have two of them does not mean that our coordination number is 2. You have to remember which ones are bidentate, and therefore the coordination number here is 4. The oxidation number, because we have two anions outside the coordination sphere that are -1, must be +2, because we're dealing with zinc 2+, right? And really, if we remember from General Chemistry 1, zinc pretty much only makes a 2+ ion. Okay? Now, if we wanted to take a look at the structure, remember, if we're dealing with zinc 2+, and we're dealing with a tetrahedral molecule, how do we know that? Because we're dealing with a coordination number of 4. And I'm going to draw this, and I may not expect you to draw this perfectly, but remember, we have a carbon, and then we have another nitrogen here, where these are bound to H's, same here. And you'll see these kind of diagrams and drawings in the text. Remember, we're dealing in 3 dimensions. This is just in the plane of the paper, and this one is not. So we're dealing with an amine here, and an amine here in both of the bonding areas. And now we have what is zinc 2+ with the ethylene diamine in tetrahedral structure. It has a 2+ total charge, and we have our 2 bromide ions outside of the coordination sphere, right? So you need to be able to tell me all of this, plus give me a rough sketch of the molecule, and then let's look at some nomenclature. We're dealing with a different situation. When we're dealing with En, or ethylene diamine, bidentate, so bidentate ligands use a different prefix. Bidentate ligands are going to use the prefix bis, bis, and then for 3, tris. So we're using different ligands for bidentate. So we're going to deal with bis ethylene diamine, which is the 2 ligands, bis ethylene diamine, zinc. And remember, zinc is not a transition metal that has multiple charge states, so we don't need a Roman numeral. And we're dealing with an anion of bromide. So the difference here is, instead of using biethylamine diamine, we're using bis, because we are dealing with a bidentate ligand here. So those are 3 examples of nomenclature, structure, and coordination number, oxidation number. If you have any questions, make sure to leave a comment, let me know.